One of the areas of my study and interest is the subject of intelligent design. The evidence for design in the universe is overwhelming. It is overpowering. God's invisible attributes, his eternal power, divine nature have been clearly seen, being understood through what? Through what has been made. The heavens declare the glory of God. I mean, all of that. God has so created that he has left a vapor trail. I mean, he has left fingerprints all over the place that it really points to himself. And so intelligent design is it was one subject that I knew we had to have at this conference. And I'm very, very excited to have Dr. Paul Nelson as our presenter on this subject, the power and promise of intelligent design in biology. If you are familiar with those intelligent design DVDs that I mentioned before the break, he is a frequent contributor to that, and for good reason, because he's very clear and succinct and articulate, and he has just a great background in the hard sciences and a deep knowledge of evolution theory, but also the evidence that counters that. And so here, Dr. Paul Nelson is going to bring this next lecture. Educated at University of Chicago, has a PhD in the philosophy of science. He's an adjunct professor out at Biola. And so it's a great joy to have Dr. Paul Nelson be our next speaker. So let's welcome Dr. Paul Nelson.
I have to tell you, it is great to be back here in Texas. By God's providence, I think I've been spending a lot of time here this fall. In September, I was at SMU. About a week ago, I was in Austin, and now here I am in Denton. And I have to tell you, for someone who lives in Chicago, it's warm down here in lots of ways. And we don't have any live oaks in Cook County, Illinois, one of the most beautiful trees in North America. Now, the next hour is going to be more biology in more detail than you ever would expect to hear in a church on a Friday night. But that's okay. That's okay, because God is in the details. After all, he made them. He put them there for us to discover. But before I get to the biology, I want to set the stage and give you a little bit of background about why this matters. Now, both Craig and JP told stories from their personal life, and I'm going to do that too. In fact, I'm going to start with that. In the early 1980s, I was a student at the University of Pittsburgh studying the philosophy of science and evolutionary biology. Those were my majors. And one of my mentors was a distinguished philosopher of science named Adolf Grünbaum, who's actually interacted in print quite extensively with Bill Craig on topics of expertise for both of them. He's an atheist. Grünbaum is an atheist, but he was one of my mentors and a very kind man. And I would go to his office in the main building there at Pittsburgh to have meetings with him, and this face would look down on us, because that picture sat right above his desk. As many of you know, that's Bertrand Russell, the great logician, mathematician, philosopher, educator, and atheist, one of the most dominant personalities in academic life in the 20th century. And Russell grappled with the question of God's existence. In fact, he wrote a famous book with the title, Why I Am Not a Christian, that perhaps some of you have read. So I'm sitting there in this office meeting with Grünbaum, who is himself an atheist, and that face is looking at us, and I feel like it's 2-on-1. Because Russell's presence is saying no logical fallacies allowed, only evidence, only clear thinking in this office. Now, at the end of his life, I believe it was in the 1960s, Russell lived a long time, and he was asked what he would do if after his death he came to, so to speak, and found God standing there looking at him. How would he respond, given that his life and the arguments that he made supported atheism? And this was his reply. He didn't give me enough evidence to believe that he existed. The evidence was too paltry. There wasn't enough there for me to affirm God's existence. Now, we'll come back to this point in a few minutes on the question of design. I'll come back to Russell. But Russell, early in his intellectual life, decided that science, the discipline of science, of natural science, had taught him or told him certain truths about the world. And I want to read those to you because they form the core of the worldview that J.P. described before the break called scientific naturalism. This comes from a famous essay of Russell's called A Free Man's Worship. And I'll read this. It's actually very eloquent. He was a wonderful writer. He would write pages and pages and pages with never a single correction. People were amazed he could do that. Such an outline, but even more purposeless, more void of meaning is the world which science presents for our belief. Notice the capital S there. That man is the product of causes which had no prevision of the end they were achieving. That his origin, his growth, his hopes and fears, his loves and his beliefs are but the outcome of accidental collocations of atoms. It's a little bit of fancy language there, but the picture is that reality is physics at its base and nothing else. Matter and the void colliding with each other gave rise to you. He concludes this passage, all these things, if not quite beyond dispute, are yet so nearly certain that no philosophy which rejects them can hope to stand. Now notice what he is claiming for the authority of this position, not a worldview, not materialism or naturalism or atheism, but science. I'm sure that many of you know that the Latin root of the word science is knowledge. It means knowledge, scientia. So he's saying we know this. This is what science has delivered to us at the beginning of the 20th century. He wrote this as actually a rather young man, 1903. So if you're a Christian or a theist, or you maybe don't know what you believe, but you think God might exist, Russell is saying you have to fit that picture of reality with the knowledge that science has provided to you. Now, as a student at Pitt, in this course with Grunbaum, I had to read this and confront it. And it struck me that what was being claimed in the name of science was actually no such thing, because at the same time, I was reading science. I was reading, for instance, the works of this great man, Isaac Newton, lived 200 years prior to Russell. And it was Newton's view that evidence clearly indicated that our world had an intelligent cause, a cause with a mind like ours, but vastly more powerful, but in some sense like our mind. Here's how Newton put it in his Optics. Was the eye contrived without skill in optics, and the ear without knowledge of sounds? These things being rightly dispatched, by that he means well constructed, that we can observe them, does it not appear from phenomena, that is, from the evidence of nature itself, that there is a being, incorporeal, living, intelligent, omnipresent? That's God. Just in case you missed the drift there with the capital B. And though every true step made in this philosophy brings us not immediately to the knowledge of the first cause, yet it brings us nearer to it, and on that account is to be highly valued. It's a famous passage from the Optics. So if we go back in time to the foundations of Western science itself, in the scientific revolution, the central figure of that revolution, Isaac Newton, is saying, evidence clearly affirms that this world had an intelligent cause. Now what's happened in that 200-year interval? Well, we can build ourselves a little timeline. What happened to the evidence from Newton to Russell? So there's our timeline. There's Russell in the 1960s. There's not enough evidence. When I meet God after I die, he's going to hear it from me that he did a poor job of testifying to his own existence. We go back to Newton, and Newton says it's unequivocal. There's no doubt that the data of nature point to an intelligent cause. What is intervening in that slightly more than 200-year interval? It's Darwin. It's natural selection. Russell after Darwin, Newton before. And it's the process of natural selection that Russell and other intellectuals like him in the 20th century would have said, and did say, robbed the data of biology, what I'll talk about in a moment, of their power to persuade. Where Newton thought that the eye indicated an eye maker. He said it's clear from the phenomena that that had to happen. That's gone by the time the 20th century rolls around, and the reason is Darwin proposes a process, natural selection, that is supposed to explain what we see that appears to be design without a designer. Now this view, as you know, is very widespread today. So Richard Dawkins used to be a professor of zoology at Oxford, now a full-time atheist, put it this way. When he was still doing biology, the theory of natural selection provides a mechanistic causal account of how living things came to look as if they had been designed for a purpose. So you've got the eye, you've got the cell, a blue whale, an oak tree, and it seems to give evidence of beneficent purpose, of an intent, of a mind as its author. And he said, you know what, that's an illusion, because I've got this process here, natural selection, that's going to build that oak tree for you. It's going to build that blue whale for you. And when you look at that causal process and take it to pieces and analyze it, you will find no mind there. There will be no intelligent cause there. This view is very widespread. In fact, if we jumped in a bus and went to the local universities here and grabbed a biologist, just picked one at random, they would say, that's right, natural selection does do that for us. Here's another example, Ernst Mayr. Probably the most influential evolutionary biologist of the 20th century, had a very long career at Harvard. He put it this way, at about the same time that Dawkins was writing, the real core of Darwinism is the theory of natural selection. The theory is so important for the Darwinian because it permits the explanation of adaptation, the design of the natural theologian. That is what Newton would have seen as evidence for an intelligent cause. That can be explained now, he's arguing, by natural means instead of by divine intervention. So that's the background for what we're going to talk about in biology. To understand, in other words, what happened to the evidence from Newton to Russell, we need to ask what cause best explains the data of biology, natural selection or intelligent design. Now, I want to come back to Russell briefly before we jump into the biology. Here's an important historical detail that is too little known. It's an interesting fact about Russell. Russell had a high regard for the persuasive power of the design argument. A very high regard for it. He was skeptical of almost all arguments for God's existence in terms of their logical strength, except the design argument. Here's how he put it in his History of Western Philosophy. This argument contends that on a survey of the known world, we find things which cannot plausibly be explained as the product of blind natural forces, but are much more reasonably to be regarded as evidences of a beneficent purpose. Now that's a very nice, clear expression of the design argument. He goes on. This is the remarkable passage. It's too little known. This argument has no formal logical defect. In other words, its logical structure is sound. Its premises are empirical. They're based on evidence. And its conclusion professes to be reached in accordance with the usual canons of empirical inference. Now that's a lot of fancy words. What he means is that if you went to a movie with a friend or your spouse and came out afterwards and approached your vehicle and you saw that the driver's side window was broken. There's glass everywhere and you look inside and your Garmin GPS is gone. This actually happened to me, by the way, at the University of Chicago in March. And it was cold and I had to drive all the way home to my house 20 miles away in about 30-degree weather with that window completely gone. And the Garmin was gone. And your digital camera is gone, but the McDonald's bag and the old atlas of Denton, Texas are still there. Now, you laugh, and that's because everyone in this room, and if we filled the empty sections with atheists and agnostics, they would agree with us. Everyone in this room, when presented with that pattern, is going to make one inference and one inference only. And the very last thing you're going to do is sit down on the curb and start running through all the natural processes that can get only the valuable objects out of the car. You see that pattern, you pick your phone, 911. That's what I did. That's what anyone would do, because it's part of our rational toolkit as human beings that certain patterns that we see in the world trigger an inference not to a physical cause, but to a mind, to an intelligence, to someone who said, I could get $200 for that Garmin, break the window and take it. And we know this with certainty. In fact, these inferences that we make to intelligent causes are among the most stable things that human beings know. Example, in the 1st century AD, the island of Britain was becoming a colony of the Roman Empire. And at that time, Stonehenge was already an ancient site, already hundreds and hundreds of years old. At one point, Roman soldiers riding over a hill, they saw that arrangement of monoliths there. Probably some of you have visited it outside Bath in the UK. And they made an inference. They were probably pagans, and they said, somebody put that together. Monoliths of that size do not arrange themselves into circles that align with the summer and winter solstice and so forth. That was true in the 1st century AD. It's true today. It will be true when the universe ends. Current theories of physics like string theory will be long gone, and the inference that Stonehenge was caused by intelligence will still be true. Recognize this, that these inferences to intelligence that you make every day, whether you're conscious of it or not, are among the most stable things that human beings know. They're remarkably robust. So, sorry for that long digression, but that's what Russell is saying when he says here the canons of empirical inference. So how does he conclude? The question whether it is to be accepted or not, that is the design argument, turns therefore not on general metaphysical questions, that is, remaining within the realm of philosophy, but on comparatively detailed considerations. Well, there's an interesting phrase. What does he mean by that? What he means by that is this. You've got to look at the evidence and you've got to dig deep and weigh what kind of cause can explain the evidence in front of you. Now, if I have one thing to tell you tonight that I hope you will remember, it's use your mind. I want to strongly endorse what JP said before the break. God gave you a brain, use it. He told us to love him with our heart, our soul, and what else? Use it. Don't be afraid of science. And if you find a science intimidating, as much of modern science is to Christians, the best solution is not to run away, but to go deep into that science and learn it thoroughly, which is what I have done with evolutionary theory. Because the world that God made will reliably testify to his existence. And if there's a scientific claim that bothers you, you need to probe it. So that's what we're going to do for the next, 40 minutes. Let's try a case study in the kind of evidence, the kind of biological puzzle that Dawkins and Mayer in modern biology say natural selection explains. Now, what I'm about to show you is footage from a film that's coming out next year. It'll be out in 2011 from the same producers that made the movies On the Table Outside. This is footage that has not been shown to the public before. And there's a message here. I'll try not to talk over the film. It only lasts about 90 seconds or so. But I want to tell you the reason I'm showing it to you. A few years ago, I was interacting with a microbiologist at the University of Chicago named James Shapiro, who is an evolutionist but not a Darwinian. I went to his lab because he had written a book review of Mike Behe's book, Darwin's Black Box, which probably some of you have read. And it was a largely favorable review. So we're sitting in his lab talking. And he interrupts me at one point and he says, Paul, what you guys need to do, meaning you intelligent design advocates, is just get out of the way of the evidence. Let people see the evidence of biology and it will have all the persuasive power that you need to make a case. And he was right. In fact, shortly after that, at a seminar at Wheaton College, he out-Behe'd Mike Behe. Mike Behe was there at the seminar. Shapiro got up to speak. And there are 300 science students from Wheaton there. And Shapiro said, I want to show you just what goes on when a cell turns DNA into protein. And by the time he was done, their mouths were all hanging open in astonishment. So let's look at a little bit of the evidence. That's an Australian birdwing. It's about this big. It's amazing. Oh, that's courtship behavior. The male is on top. He's blasting her with his pheromones. It's the butterfly equivalent of saying, "Hey, baby." They're on their way to Mexico right now, the monarchs. All right. Does natural selection explain where butterflies came from? Well, you know what? The great thing about natural selection as a theory is it's been so well articulated, so clearly laid out, that we can use the theory to test itself, to test its own power. To do that, though, we're going to have to go into a little detail. And I said that at the beginning, and I'm sorry, there's no way around it. If you want to understand how natural selection fails, you have to understand the contexts in which it works. So let's jump in. We have to have a formulation of natural selection that we can use to examine that puzzle. Where did butterflies come from? So this is expressed as a conditional. It says, if the following conditions exist, natural selection will occur. The first thing we need is variation. Now, if you look around this room, you'll see plenty of variation. There's tremendous variation just within the species Homo sapiens. Hair color, height, skin color, you name it, there are differences present. Now, if those differences in some population make a difference to the number of offspring you have, and if you can transmit the basis of those differences to the next generation, natural selection will occur. It follows just as night follows day. It's bound to happen. This is a real process, and there's plenty of evidence for it. My wife is a pediatrician, pediatric gastroenterologist actually, but when she did general pediatrics, the American Academy of Pediatrics wanted her to put up a poster in her waiting room that told parents, in effect, don't expect to go home today with an antibiotic. Because people abuse antibiotics. You may have done this. I know that in our family this has happened. Your kid's got a fever, let's say 103. You take him to the doctor. You get an antibiotic. You give the drug until the symptoms go away. Let's say 5 days, 7 days. The prescription is for 2 weeks. But the symptoms go away. It's a pain to give a medication to a child, so you put the rest of the antibiotic in the medicine case in your bathroom and you forget about it. The problem is, the next time that bacterial species sees that antibiotic, it's going to go right around it because natural selection is real. And bacterial populations are very large. They have a lot of variation. They're going to find a way around that if you don't use it right. So in effect, right now, the bacteria are winning. And they're winning in part because of the reality of natural selection. So this actually happens. The question is, does this kind of process, which is real, explain where bacteria themselves come from, or butterflies, or oak trees, or blue whales? Now, that was a lot of words, so here's a little cartoon to show you how this works. Let's say we have a single-celled species, and it's got an orange trait and a yellow trait, whatever that happens to be. And we introduce a selective condition that favors the yellow trait, so that the orange trait can't reproduce as much as the yellow trait, or the organisms possessing the yellow trait, And if we maintain that selective condition, represented here by the black line, you can see that over time, the character of that population as a whole is going to shift. This is what happens, for instance, with bacteria in the presence of antibiotics. So that if we take out the middle generation, you can see there's been a change over time from starting population to the ending population. Now, we've got these three requirements. Let's keep them in mind because we're going to use them to test claims about evolution that use natural selection itself. Got to have variation. It has to make a difference to the number of offspring you have, and you've got to be able to pass it on. And that's like having three legs of a stool. They're all necessary. These conditions are necessary for natural selection to operate. If one of them is missing, natural selection can't work. Hang on to that point because we're going to use it when we come back to look at butterflies. You can think about it this way. If you can't leave offspring, in terms of natural selection, you are invisible to the process. You're a dead end. So you could imagine having some guy in much better shape than I am, like Michael Phelps, Olympic swimmer, tremendous physique, who has the brain of Albert Einstein. Furthermore, he's got the charm of a Hollywood actor. This is a really superior human being. Every feature that you consider when you look at him is optimal. One small problem, he's sterile. And the poor schlub, shaped like a pear like me, that has 10 kids, is out-competing that guy who's sterile. Because all that matters for natural selection is that you pass on copies of your genes to the next generation. Keep that in mind. We're going to come back to it. Now, Dawkins says that process explains the design that we see in nature. He's built a career taking that claim into the public and telling people, you see design in those butterflies. It seems to be there, but I'm telling you that's an illusion and natural selection can explain it. Well, here's a little secret. Many evolutionary biologists, not like me, not intelligent design advocates, don't believe it, and they haven't for a long time. Even in the middle of the 1960s, when the neo-Darwinian theory was at its zenith, it was dominant in biology. There were plenty of biologists, like this gentleman, Conrad Waddington, a very influential English geneticist and evolutionary biologist, who didn't believe it. And in a famous meeting in Philadelphia in 1966, he said, the real puzzle of evolution, how do you come to have horses and tigers and things, is outside the mathematical theory. By the mathematical theory, he means the theory of natural selection. That what we really want a theory of evolution to do, if it's going to work, namely tell us where horses and tigers and things came from, is not performed by natural selection. But he's hardly alone. Wallace Arthur is an English evolutionary biologist. I met him actually when I was a graduate student at the University of Chicago because he came there to do a sabbatical in the late 1980s, about the time that he published this passage. And he's asking about the problem, where do living things, organisms, animals in particular, come from? And he can say, look, we have no direct evidence for the Darwinian origin of a body plan. A body plan is the basic architecture that you see, let's say, at the seashore. Here, if you go down to Corpus Christi, you'll see a sand dollar that has a five-fold symmetry, and you can distinguish that kind of organism from an arthropod like a crab. These are major differences, and we want evolution to explain them. And he said, Arthur here says, we don't know. Biston betullaria, that Linnaean binomial, is the name for the famous peppered moth of England that probably many of you learned about in biology. He said, if that's what evolution is all about, then we don't really understand evolution. In the end, we have to admit we don't know how body plans originate. Now, this is 1987. This is a long time after Darwin. What has evolutionary biology been up to if it can't explain where animals come from? That's what I want the theory to do. I'm not interested, well, I am, but it's not really the main problem, in minor amounts of differences of pigment in one fly versus another or one moth versus another. That may be relevant for ecology and lots of things. I want to know, where did the moth come from? Why hasn't this problem been solved? Well, the reason it hasn't been solved is when you look at the way that animals are built, In a sense, the very last thing they want to do is evolve as evolution requires. Now, I'll explain what I mean by that by going back to one of my heroes, actually another atheist, Francis Crick, one of the co-discoverers of the molecular structure of DNA with James Watson. They won the Nobel Prize for that in 1962. And Crick was well known as a kind of gadfly in the biological community. Very, very bright guy. World-class theoretical biologist. And people would come to work with him and he would buttonhole them. Kind of stick his finger in their chest and say, you don't really understand the problem you're trying to solve. He was notorious for doing that. So in the early 1980s, Gabriel Dover, who's an English evolutionary biologist, went to Southern California to the Salk Institute in San Diego to work with Crick on the problem of macroevolution. And Crick intimidated him and he said, look, you're not going to be able to solve the problem of macroevolution until you understand how organisms are put together. Now there's a very interesting phrase. I remember when I read that, it kind of jumped off the page at me. What does Crick mean by that? Well, let's say we have a species that has a triangular shape. Now this is a PowerPoint cartoon. Obviously real organisms are more complicated and interesting, but I want to make a very simple point here. Evolution is not mainly a theory of similarity, it's mainly a theory of transformation, of changing things. So we start with A is our starting creature, and we want to evolve A into something like B. We're going to change its overall shape in a dramatic way. Something that if I saw it in a real world biological situation, I would say, you know what, that's macroevolution. Well, if species A and species B are animals, we're animals, your dog's an animal and so forth, they're going to be constructed by a developmental process. They're going to be built. Starting with a single cell, a fertilized egg, a developmental process will begin in which the cells divide and specialize for particular functional roles. And depending on the species in question, that path may be short, as it is for a fruit fly, or it may be long, 9 months in our case, actually much longer than that when you talk about sexual capability. For humans, it's not until you're well into your teens. So that's a long developmental pathway until you can actually reproduce yourself. But that's what's going to happen. You're going to start there, and there's a construction process that's going to build A for you. So if you want to change the shape of A, and A is an animal, you have to change the way that A is built. You're going to modify the construction process. You can think about this in terms of an automobile factory. If you've got a factory that's building cars with internal combustion engines and a particular arrangement of their transmission and axle and so forth, and you decide, you know what, no more cars with 2 axles and 4 wheels. I want vehicles with 1 rear axle, a single wheel in the front, and electric motor. You can see that that kind of transformation, if these are vehicles, is going to mean you've got to change the building process. Starting back here, you're going to have to change the way that you construct the entity in question. Well, that's the problem of macroevolution, at least for the animals. Now, here's an important point that will be essential when we come back to butterflies. This can't happen. So here's our evolutionary transformation that we wish to cause. And let's say these are the developmental pathways leading to A, and then B is going to be a more complicated process. You can't have a stage where you're chugging right along and then you say, you know what, I'm going to be dead for a few hours. It's all the same to you. I'm just going to shut down, and natural selection will find a way to get things up and running again. But for the next day or so, no activity, no metabolism, nothing, I'm dead. If you see a stage like that in an evolutionary hypothesis, you can know on those grounds alone that it doesn't work. Because the one thing that has to be maintained in an evolutionary pathway is viability. You've got to be alive to evolve. Kind of essential. So, these pathways, these developmental pathways, are very complicated, and they have to reach their goal. Once you start to divide, you're a cell, you divide to 2, to 4, to 8, and so forth. You're beginning that process of cell division and differentiation. You've got to get to your goal, which for natural selection is reproductive capability. So if we think about our gorgeous female monarch here, That's a long pathway, and there are some very interesting stages, as you probably remember from high school biology along the way. We'll come back to those in a moment. You can think about this like a magic bridge, in fact. If you don't have any developmental biology in your background, it doesn't matter. Just keep this metaphor in mind. It's actually fairly useful. Here's a chasm. We don't really have these in Illinois, but I know you've got them here in Texas. I saw them in Austin driving around. Imagine there's a river down there. Let's say that's 1,000 feet deep. Big chasm. There's plenty of them in California and out west. And there's our magic bridge that spans that chasm. Now, development is a magic bridge in the following sense. Imagine this like a kind of Spielberg movie, Raiders of the Lost Ark or something like that. You start over here. There you are. You're walking. And as long as you keep walking, the bridge will be there beneath your feet. The minute you stop, it disappears, and you plunge down. So once you start, you've got to keep going to get to the other side. Don't stop walking until you get over here. Now, the analogy to development is very, very striking. You can take an embryo that's growing in culture, in a flask, if you will. It's dividing, and you can put in a chemical that stops cell division. It arrests mitosis, the process of cell division. You put that chemical in, you stop cell division, the embryo is going to die because it's somewhere out here in the middle of the bridge. And it's got to get over here to the adult form to survive. And in particular, if natural selection is going to operate, it's got to get over here. Now, that may be a little tricky, so here's a toy animal to help you see why this is a problem. Real animals are much more complicated, obviously. So this is a little toy animal. It's got 16 cells arranged in this pattern of 5 different types. And in order for it to reproduce, it's got to have those 5 different types, and they've got to be arrayed in that order. Now you say, well, that's not hard. I could imagine evolving that. Well, think about it this way. Think about the construction process, because we're going to start not with 16 cells, but with 1. So there's our starting point. That's our fertilized egg. And I don't want to tell you how long it took me to make this in PowerPoint. But what you can see here is a branching decision tree. What's the most important node in that decision tree? The first one. If the first one doesn't go right, everything downstream will crash. So this first cell division sets up these 2 daughter cells. They divide and so forth. And this is a very, very, very simple animal. There is no animal as simple as a 16-cell creature with only 5 cell types. Even the simplest animals we know have hundreds of cells of very specialized types and geometries. Well, here's the problem for natural selection. To get the animal that we want, our little toy animal with these 16 cells, we've got to put all these instructions in place. But it's not until the instructions are there that you have an animal that's capable of reproduction. So natural selection can't build that for you, because natural selection only works when it's all put together. What provided all those instructions? And you can test this by arresting the process. Let it run, and then stop it prematurely. So let's say at this point we put in that chemical that stops cell division. That's dead. That's going nowhere. Well, if you reflect on the realities of development, there's a real problem for natural selection as a mechanism. Our magic bridge only works if we get over here. So how did we build the bridge if we had to keep walking? And we've got to get over there, and it's only here that natural selection can operate, because remember those 3 conditions: variation, heredity, and selection. Heredity can only operate if you can make copies of yourself, if you're sexually mature, meaning you've made it over here. Now, I'll come back to this slide, but I want to put it in your mind. You've seen this magic bridge. You've seen that developmental process. What you see in those little toy examples, but you're going to see in more detail with butterflies in just a moment, is a process that's end-directed. In other words, it's heading towards a distant target. Now, think about your experience. What kind of cause can aim at a distant target that can say, you know, it would be really nice to have a device that would put a bright green dot on a screen. And let's see, I'm going to need a power supply, I'm going to need a lens, I'm going to need a chassis to hold the whole thing together, and a button. I'm going to need something to make the bright green dot. I'm going to need all these independent elements to be brought together to achieve a distant functional goal that I can imagine but doesn't yet exist. What kind of cause can do that? What kind of cause can reuse modules? The great Nobel laureate Barbara McClintock, who had powerful discoveries in genetics and was kind of an outcast in science for a long time. When she looked at the butterfly, she said, the amazing thing about butterflies is you have two animals linked together with one set of DNA. Two fundamentally different ways of living, caterpillar and flying insect, and they're using the same DNA. Which means that for one part of the life cycle, the genes are being used in one way, you go through a major transformation and you reuse the genes in another form. What kind of cause can do that? Think about the electronic systems that you have in your home. Many of their components are identical. You open up your DVD, you open up your laptop, you open up your cell phone, you're going to find many of the same circuitry elements present there, but they're reused in different contexts. Why? Because the designer says, you know what, this is a great little transistor, I'll use it here, here, and here, but I'll use it in a microwave in this instance, and in this instance in a Blu-ray player. And what kind of cause can build major differences between systems? In your experience, we'll come back to that slide. Now, I'm showing you this to give you a flavor for the problem that a butterfly faces as it develops. This is Houdini. It's a little difficult to see, but there he is. And he has three assistants here, and this is a water-filled chamber. And they're lowering him in. What is the one thing Houdini will not allow himself to do as he's being lowered into that box? He's not going to breathe, but he's not going in without a plan to get out. There's a horrible, grisly clip on the web. I shudder that I ever watched it, of an amateur magician, escape artist, who built a container and was lowered into sand. He didn't have a plan to get out. The thing collapsed, and he suffocated. You can be sure that as Houdini goes into that box, he has probably his main plan to get out, plus 2 or 3 backups in case the first one fails. Okay, keep that in mind, because you're going to see the problem that the butterfly faces is really, in many respects, identical. Remember, we can't go through this stage. If we're going to evolve A into B, that can't happen. It's not possible for that to be the evolutionary pathway by which B evolved. So let's go back to the butterfly. This is a female. The males have little spots here on either side of the abdomen where they have scent glands for courting females. And probably you remember from high school biology the life cycle of the monarch. Now we can really pick this story up at any point, but let's start here with the female laying her egg. And if you've seen this happen, when the egg hatches, the caterpillar is very, very small. You can barely see it. But in a matter of just a few days, it's easy to see because it's growing really, really rapidly. Caterpillars increase their weight hundreds of fold. If you had human babies, they would be like 25,000 pounds over the same interval. You probably remember is it a Pixar movie with the caterpillar character? He's always eating. Well, that's what they do. They're eating machines. So let's pick up the story here where you have the full-grown caterpillar, and after a series of instars, of molts, when it sheds its skin, it attaches itself at its rear to a safe, secure spot, forms this characteristic J shape, and then starts to spin around to make sure it's not touching anything. Because if it is touching anything, the formation of the pupa will not occur correctly. Forms the pupa, or the chrysalis, and then the real mystery is what happens in this stage. We'll come back to that. But depending on environmental circumstances, there's a 7 to 10 day interval here when the adult butterfly is being built. Then it emerges from the pupa, pumps up its wings, forms its proboscis, this long straw that it will use to feed, and then the whole cycle picks up again. So in Cook County, where I live in northern Illinois, we had a really good monarch crop this year. And there's a park near our house that has a lot of milkweed. That's the only food that monarchs eat. And if you lift the underside of a leaf, you can see the monarch eggs. They're gorgeous, beautiful little structures. In a scanning electron micrograph image, there are just incredible details here, and there are little breathing holes at the top there. Out hatches the caterpillar, eats. We get to this stage when it forms the pupa. And in May, for this movie that's being produced coming out next year, I watched this happen at the University of Florida, and it's amazing. There are multiple steps involved. One I want to focus on is how it suspends itself from the surface here. Now, you may not be able to see this. Sorry, it's a little difficult to see. I'll skip to the next one. This is the cremaster. This is the structure at the hind end of the caterpillar by which it suspends itself from a silk pad. So it spins a silk pad with silk fibers here, and this is kind of like a Velcro attachment. This one you'll be able to see a little bit better here. See these little hooks? They entangle into that silk pad, into those silk fibers, just the way that if you have Velcro at home, put the two together, it's really hard to pull them apart. Now, if you think about this from a kind of engineering perspective, why have these little hooks if you don't have the silk pad? If you don't have the behavior to spin the silk pad, or the organs even to form the silk? But why have the silk pad if you don't have these little hooks? You need both of them. You can see that the problem of engineering just a caterpillar is going to involve a lot of these interrelated systems. All right, there's the mysterious stage, the really mysterious stage. You know, the name chrysalis comes from these little gold dots on the surface of the chrysalis. The Greek root of that word chrysalis means gold, and no one knows what they do, really. There's an interesting research problem to be solved there. Now, what's going on in this stage? Two things mainly. As I said, it lasts a week to 10 days, depending on conditions. Two things are happening. The first is the caterpillar is digesting itself. Literally digesting itself. Only a few tissues survive from the caterpillar stage to the adult, like the heart. The heart's always there. But most of the tissue of the caterpillar is literally being chewed up by powerful enzymes. Processes called apoptosis and autophagy. That means eating yourself. So if in day 1 or 2, I'm too tender-hearted to do this, but some biologists do it to learn what's going on. If you dissected the chrysalis, cut it open, and poured it out onto a slide, it would look like Jell-O. Soup, if you will. The caterpillar is chewing itself up and taking those materials and turning them into the structures of the adult. But there's a second process going on. In the caterpillar, there are cell populations that are set aside, that are not used in the caterpillar stage to build the structures of the adult, that have no counterpart in the caterpillar, such as legs, genitalia, this long proboscis that it uses like a drinking straw, and so forth. Well, let's jump ahead to the end of the story. Near the end of that stage, the chrysalis darkens rapidly, and you can really make out the structures of the adult there, and then, of course, it emerges. And you saw a little bit of that in the footage that I showed you. Now, this is a really interesting stage that at least once in your life you should see occur. As the adult butterfly emerges, it's doing lots of things to prepare itself for its second part of its life. One thing it does is it pumps up its wings, pumping fluid from its abdomen through these veins to extend the wings out to their full size, and then they need to dry so they'll stiffen. But it's also putting together its drinking straw, its proboscis. If you look at a proboscis in cross-section, there are two halves. And what it's doing is unrolling them like this so that they'll join. Half a straw is not a straw. If this thing is going to feed, it's got to unroll, it's hard to see on the slide here, it's got to unroll that proboscis and knit it together to make its main feeding structure. So there's a lot going on. It doesn't fly until it's ready, until the wings are stiff and everything's ready to go, and then off it goes to find a mate. Well, let's go back to Houdini. Remember, he's not going into that box until he has a way to get out. He would never let himself do that. Probably a couple of backup plans, in fact. Well, you know what? The caterpillar faces the same problem. It faces the same problem. What creature is going to digest itself unless it has a plan to get out the other side? That would be death. If you went into this stage without the instructions to get out the other side, it's over. You've turned yourself into soup. Now, let's go back to the requirements of natural selection, and let's stick to them very tightly. It looks like to go from a caterpillar to a butterfly, and we're adding these stages in evolutionary history one at a time, we're going to have to come to a stage where we don't know how we're going to get out of there. Because natural selection is not like you and me. It has no foresight. It can't see a distant target. If something is going to be selected for its function, it's got to work now. Not 10 million years in the future, now. So if natural selection built the butterfly, it would have had to pass at some point through a stage where you've got neither caterpillar nor adult butterfly. What you've got is a bunch of goo. That cannot happen. So if we take this evidence seriously, the butterfly could not have evolved by a Darwinian pathway. It's impossible. Darwin knew this 150 years ago. He expected the problem to be solved. 5 generations later, it's not solved, and it's much, much worse because we know what's involved. We know the details that have to be satisfied. Natural selection cannot build these networks for you. Because let's say we have a little simple 5-cell creature here where these cells need to be aligned in this pattern, and that's when it has reproductive capability. It's only here that natural selection can begin to operate. So what put those instructions in place to get you over there? Given that natural selection only operates at this point. So you might ask yourself, well, Paul, how do organisms solve the problem? Mom and dad. You need the whole life cycle of a butterfly to have any part of it. If you want a caterpillar that turns into a butterfly, you need mom and dad. This is a sexually reproducing species. You need to have the parents. That makes perfect sense from an intelligent design perspective because, after all, a designer can see a distant endpoint and bring it into existence. You want any part of this cycle, especially this mysterious stage here, you need the whole thing. That cannot be built by natural selection. And in fact, in The Origin of Species, Darwin himself said, if such a pattern existed, my theory would absolutely break down. But it's not just here. It's all through biology. In 2 weeks, I'm going to be at an event at Northern Arizona University, and I'm going to talk about digestive enzymes. Boring, you know. Ooh, Paul, that's pretty bad. That's downright boring. Digestive enzymes? Well, you know, why doesn't your stomach digest itself? If you've ever taken pepsin, which is a very powerful enzyme, and dropped a little piece of hamburger into a test tube full of pepsin, the hamburger doesn't last very long. Because the pepsin gets in there, snip, 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 and chews up those proteins. That's what's going on in your stomach right now with the contents of the meal you had for dinner tonight. Your stomach does not digest itself because when pepsin is formed in the wall of your stomach, it's formed in an inactive form. It's produced in a form that will not destroy this very cell that synthesizes it. It's excreted into your stomach, and then it's turned on. Part of what turns it on is the pepsin already in your stomach. So digestive enzymes, and in fact, your whole digestive system requires lots of features to function at all. If they weren't there, it wouldn't work. So this isn't just a puzzle in biology, in butterflies. It's a puzzle right through biology. Now, there is a hypothesis published last year for how this happened by a non-Darwinian pathway. This is Donald Williamson, who is a zoologist at the University of Liverpool in the UK. And in this paper, I'll paraphrase what's there. It's probably impossible for you to read. He says, the origin of butterflies by a Darwinian pathway is simply impossible for the reasons that I've outlined over the past few minutes. Now, here's his solution. And I want to tell you, I'm not putting this up to make fun of Donald Williamson. I actually admire his courage for proposing this hypothesis. I put it up here to show you that unsolved problems can persist so long that people will take really wild leaps to try to solve them. So here's his solution. We start with a kind of caterpillar-like form. It's called an onychophoran, or a velvet worm. We don't have them in the United States. We found them in other parts of the world. Kind of looks like a caterpillar. And we take an unknown arthropod species, like a grasshopper, that doesn't have a embryonic path like a caterpillar. So when you see a baby grasshopper, if you've ever seen one, they look like an adult grasshopper, just very, very much smaller. They have what's called direct development. And we hybridize the two. Take them to a single spar. It's like, I know it doesn't look like the grasshoppers you're used to, but, why don't you guys have a couple of margaritas, see how it goes, and we get a viable hybrid. That's his solution. If you want an organism like a butterfly that has two profoundly different stages, take one from a group that kind of looks like a caterpillar, marry that to one that has the arthropod features that you want, and get a viable hybrid. Now, it's a brave hypothesis, but that's never, ever going to happen. Ever. That would be like you hybridizing with a clam. It's not going to happen. The genetics alone sinks the proposal. But Donald Williamson is a brave enough biologist to say the Darwinian attempt has failed. We need to try something new. We need to try something radical. Now, after this paper was published in a very prestigious journal, the Proceedings of the National Academy of Sciences, the National Academy was so upset that they changed the rules for submitting papers. What happened was Williamson was friends with Lynn Margulis, who's a rather unconventional biologist, but a member of the National Academy. She fast-tracked the paper on a special route into the journal that was allowed for National Academy members. They can do that. And the National Academy was so upset that they closed off that pathway. You can never do that now. It's over. So a paper like this happened under special circumstances that no longer exist. And the point is, unsolved problems can persist, not because you haven't tried hard enough, but because you're asking the wrong question. When you see something like that, the magic bridge of development, and what it triggers in you is a response that says, I need a special kind of cause for that. You need to pay attention to your intuitions. Don't step on them. Don't step on your intuitions. And don't let anyone intimidate you out of them. That's a signal put in nature for you to respond to. For this kind of cause. And that kind of cause, universally in our experience, is this. That's what can bring about butterflies, not an undirected Darwinian pathway. It's perfectly rational, and the reason we're not allowed to infer it in biology in the 21st century has nothing to do with the evidence. It's not an evidential question. It's a question of what are we going to allow as an explanation for things like butterflies. Now, you might say, if you're skeptical, Paul, stop. Enough. This is just God of the gaps reasoning. Well, here's another thing I'd like you to take home. There are lots of gaps in our knowledge right now. We don't know lots of things. We don't know how cancer happens. We don't really know how development is regulated. We have all kinds of puzzles that we wish to fill with knowledge. But not every gap that we think we have is going to be filled with knowledge. Because the gaps that we have are gaps in our understanding. And if we're putting the wrong question to nature, nature is not going to give us an answer if it doesn't exist. And you can ask the question all day, and if nature herself doesn't respond, you need to listen to her. So here's a little hypothetical to get you to see the point. So it's 50 years from now. I hope I'm still alive. Jesus hasn't come back. We haven't blown up the planet. And I have a nephew, that's Mars. I have a nephew who's working there. We've got, let's say, hundreds of thousands of people on Mars, and I'm bored. I'm living in Florida on retirement. I want to talk to him. So I get out my cell phone, and I punch in his number. And I have an unsolved science problem. I want to have a conversation with my nephew on Mars working in his lab in real time, just the way that you're listening to me now in real time. And if we had a Q&A, you could respond to me in real time. We can have a conversation with no big lag. So that's my research problem. How can I, as Earth dweller, using my phone, have a conversation with someone on Mars just the way that we might at a coffee shop or here in this auditorium? Now, I can form the question as an English proposition. There it is. I can build a research program to try to solve it. But it's not going to happen. It doesn't matter if I ask the question. There's no knowledge to put in there unless our understanding of physics is completely wrong. Right now, actually it was closer in September, Mars is about 35 million miles away. And there's a speed limit on signal propagation through space. There it is, approximately. Well, you just do the math. And at best, it's going to be a 6-minute round trip. So I get out my cell phone, I punch in his number. Hey, Asa, how's it going? And then I go make myself a cup of coffee. And I come back and I look at my watch. And a little over 6 minutes later, I hear, hey, Uncle Paul, good to hear from you. Nature doesn't work the way I want it to. So the question that I'm trying to ask and answer is fundamentally ill-conceived. And nature will not give you knowledge if there's none out there to provide. So it's not that I'm putting God into a gap that will otherwise be filled. The gap has been there since Darwin. It hasn't been filled, and the reason it hasn't been filled is we're asking the wrong question. And when you ask the wrong question, the sane thing to do is to give up the question and move on to something else that you have half a hope of solving. Einstein's definition of insanity was doing the same thing over and over and expecting a different result. If you keep putting a question to nature like, how did butterflies come to be by a gradual Darwinian process, and all the evidence that you can see tells you that never happened, you need to change your question and ask something different. And use this notion to explain where it's appropriate. Now, I want to conclude, I'm running a little bit over, but I have just a few more slides, with telling you exciting things about intelligent design as a research program. When I was a student, I watched young Earth and old Earth creationists and theistic evolutionists tear each other limb from limb. They couldn't get along, they couldn't find a way to work together, share their talent, share their knowledge, form a real community. Well, intelligent design allows that because it's a big tent. It's Lee Atwater, the late Lee Atwater's metaphor for a comprehensive coalition. You've got young Earth creationists in there, and old Earth creationists, and some forms of theistic evolution, in fact, where this adjective actually makes a difference to the explanation. So it's a view of evolution in which God is actually doing something to control the process. In fact, you even have non-theistic conceptions of design, which might appear to be a contradiction, but there were such people, like Fred Hoyle, the great British astronomer. I read this book as a student, and it really impressed me. Hoyle argued strongly that the information content of living things cannot be explained by any blind search process. It's hopeless to try to do that. He said, what we see in cells, in DNA and RNA and protein, is a clear indicator of an intelligent cause. It couldn't be more clear. But for Hoyle, that designer, in some sense, had to be within the physical universe. He was a lifelong atheist. So he made the move to design, but he did not make the move to a transcendent creator. In fact, intelligent design in this Big Ten sense is not even really a specifically Christian viewpoint. And as you go back into human antiquity and out from Christianity into other religions, you will find the intuition of design present there with no specific theology attached to it. So, for instance, I'll skip through these quickly because I don't want to run too much over. Let's go back in time. See if you can guess the author. I'll paraphrase what the author is saying here. He's saying, I find it remarkable that people should believe that there are atoms colliding that builds this elaborate and beautiful world. And if someone believes that atoms by themselves colliding can build biological design or the world that we see, why shouldn't he also believe that if you put 21 letters made of gold into a receptacle and threw it out on the ground, it's like, it's a Scrabble experiment. You take 100 Scrabble pieces, put them in a hat, and throw it out onto the ground, that you could spell the Annals of Ennius. Now, there's a hint. 21 letters itself is a hint, but there's a hint. This is a classical text, all ready for the reader. I doubt whether chance could succeed in producing even a single verse. You could do this. Buy 5 Scrabble games, take the letter pieces, put them in a bag, shake them, and dump them on the ground. And those pieces that land face up, see if they give you anything intelligible. I wouldn't recommend doing it, but you could do it. We all know what the result will be. Nothing. Nothing. Now, guess the author. It's a Roman pagan. 45 years before the birth of Christ, Cicero saw this clearly. What's going on with Cicero? Cicero is built to detect design. All human beings are. There's a signal in nature that he's responding to. There's not a Christian in sight at this point. Yet Cicero, and in fact Greek philosophers generally, on one side of the question, are responding to the signal of design. 2 years ago, the University of California Press bought out a wonderful book called Creationism and Its Critics in Antiquity by a professor at Cambridge University. And in the introduction he says, I want to show you that long before there were Christians, the debate about intelligent design was raging among the Greek philosophers, with one party saying there's clear evidence of intelligence and another party saying it's just atoms in the void. And in this introduction, he says, our familiar context of the modern creation-evolution debate doesn't do justice to its antiquity, and the fact that it does not depend, in many instances, on biblical authority, whether you accept the Bible or not. Human beings perceive design, and they have other people who don't perceive it, but that debate was going on long before, hundreds of years before there were any Christians. Here's another example from contemporary science. This is a paper published in the year 2000 by two scientists arguing that the human cardiovascular system shows clear evidence of intelligent design. It's a wonderful paper. Who wants to guess their religion? It's not Christianity, it's not Judaism, it's not Islam. They're Hindu biologists. And in this paper they say there is clear evidence. Comparative anatomy points to a design and a designer. What are they responding to? They are responding to the signal put into nature by God himself that we were meant to detect and pick up. That there's design there that's real, it's objective, and you can see it and make rational inferences about it. I'll skip that one. I'll skip that one. Wallace Arthur, I mentioned earlier in the talk, this English developmental biologist who's unhappy with Darwinian theory, said what we really need in evolutionary biology is creation science. Now he says, this term carries disreputable connotations because of its frequent use by some religious fundamentalists. That's all of you, by the way. But he concludes, we really need some creation science as a major component of evolutionary theory. Why? Because there's creating to be done. And natural selection, in Arthur's judgment, does not do it. Where is the creating being done? Not by the process of natural selection. Well, my suggestion to Arthur is that he expand his toolkit. This notion of intelligence is not spooky or irrational. It's fully rational. Every human being uses it every day to understand the world. These inferences are stable. They form the basis of knowledge. And a toolkit that excludes intelligence from science is too small for the data. And some atheists themselves know this, like this woman, Jill Tarter. Jill Tarter is a radio astronomer. She is the real-life model for the Jodie Foster character in the movie Contact, which many of you, I'm sure, have seen, about the search for extraterrestrial intelligence. And this photo depicts Tarter and her co-workers at 3 a.m. in a computer room in Puerto Rico at the Arecibo radio telescope. There's a very large radio telescope built into a natural depression in the mountains of Puerto Rico. And they're analyzing software. It's pattern detection software. It's looking for patterns produced uniquely by intelligence. And I know you can't read it, but it's interesting what she says in the caption here. They, in this case being E.T., it would be nice if they sent something obvious like the digits of pi. Well, why would pi be obvious? It's a mathematical object. It's the ratio between the circumference of a circle and its diameter. You've all learned it in geometry. There's the first 500 digits. You know, pi has been solved out to, I think, trillions of digits now. Anyway, in any case, many billions. And there are web pages where you can go and you can put in your phone number, and it will tell you where your phone number is in pi. Or your birth date, you know. Mine is 091458. It's in there somewhere. The problem is, even though it's been solved out, it's a very, very large mathematical object now. It's not big enough to include your phone number plus your area code. It will be. Within your life, the decimal expansion of pi will continue, and at some point, you'll be able to put in your area code and your phone number, and they'll be in there. It's a really kind of a mystical number in many ways. But here's the point. If you're sitting there, and there's a strong narrowband radio transmission, and it's carrying these digits, you don't need to get very far here, and you have reason to open the champagne and call the New York Times science desk. Even if you're an atheist, you have reason to do that. Because mathematical objects like pi, or like prime numbers, or like other mathematical objects that we know, universally in our experience, are produced by minds like ours. So on the very slender basis of two facts for Jill Tarter, one, whatever is out there can manipulate the electromagnetic spectrum to produce a very powerful radio signal, and it would need to be a heck of a transmitter to get across empty space. But also, whatever that cause is, it understands mathematics. They could be blobs. They could have a dozen limbs. Who knows what they look like? They have a mind in some sense like ours. And we would know that with certainty. We would have detected another intelligence even if we were atheists. You can't do it if that's your toolkit, because it's too small. And here's the great thing about intelligent design. That's bigger than that. Even if I were an atheist, I would want the bigger toolkit because the universe is a surprising place. I want that notion there. You know, I have actually tools at home in my garage in Glenview, Illinois. I don't know what they do. But I'm not going to throw them away because the next day I'll need them. That crazy funky tool, I didn't know what it did. I was sitting there on the shelf for years. I threw it away and now I need it. I want this in my explanatory toolkit. And I would want it even if I were an atheist. And I would want it because if life were intelligently designed, we should be free to discover that. You know, JP talked about the freedom of Christians. It's a remarkable fact that we have greater freedom than our naturalistic counterparts. We can play with their toys and our toys. And once you can get an atheist to see that he or she has accepted a too limited view of reality, that they're giving away things that they might need, you're halfway there to persuading them. My model is work with people who disagree with you. You have nothing to fear from them. You have nothing to fear from working with an evolutionary biologist if you're interested in biology. You have nothing to fear from a physicalist reductionist in the problem that JP works on, the problem of consciousness. Because the testimony that God put in nature for us to discover is reliable. We don't need to be afraid of it. It's out there to be discovered. Every natural law that God made that we know about or that we don't know about is out there to be discovered. But intelligence is something distinct. We don't collapse this into that, which means it doesn't matter how big this gets. This will always be separate and something more powerful and different. And it's a better toolkit. Don't accept a small toolkit. And don't let anyone intimidate you out of it. Use your rationality. God gave it to you. Love him with your mind. And I ran way over, but you've been very patient, so thank you very much.